Good morning, everyone, and welcome to the TRA Virtual Academy. Schools shut, marketplaces gone quiet, streets devoid of the usual traffic, an uneasy calm prevails. A calm that is occasionally broken by an ambulance siren, raising a heartbeat or two. People nervously peeping through their windows and get back to the mundane stuff once the siren fades away. This is the impact of COVID-19, story of an insidious virus gone viral, forcing humanity in abject submission, leaving a trail of devastation as it spread and tested our readiness. We have not seen anything like this before, totally unprecedented. The scale of this crisis and its impact on our psyche, apprehension and insecurity are as pronounced as its impact on the global economy. It exposed our frailties and weaknesses. It is paradoxical. We are locked inside when the air is at its cleanest and must don masks as we step out. I am Hamad Fikri, Senior Engineer at the for Digital Innovation at the Telecommunication Regulatory Authority in the UAE. Joining me today is Andamir Bijoy, Head of IMEA, with a master's degree in International Economics Policy and Analysis, and a professional with over 7 years of experience in launching new IT projects and business developments in Russia, Europe, and the Middle East. Andamir will be talking about biometric solutions against COVID-19. NCC is one of the leading IT solution providers in the UAE and a world-renowned expert in facial recognition solutions. Andamir, the floor is yours.
Mohammed, thank you very much. Also, I wanted to thank TRA and NCC for the efforts to organize the webinar, and also for we'll try to keep the webinar today interactive. We have questions between the slides, which we want our audience to answer during the presentation. So let's start with the first question. What is the typical accuracy of face recognition in your opinion? And this question will give us a brief understanding of the audience and the experience. So if everyone had a chance to answer the question, let's jump straight into the topic. And there are a few things that we need to discuss when it comes to the biometric technologies, specifically when we talk about the face recognition. First of all, let's talk about how the face recognition technology itself operates. It can work with the video streams as well as the pictures. With the video streams, it tries to detect the faces in the frames of the video streams, and then matches it with the pictures in a database. So the probability of detecting within our biometric technology is 98%, which is very high, which performs at the very high accuracy levels. So one of the very hot topics when we are talking about face recognition is the accuracy. And accuracy is something that everybody talks about. However, it's very complex in its own analysis and understanding, because it's very difficult to measure the accuracy of the algorithm without having a huge data set or specific laboratory where these activities could be performed. So based on the different international studies and independent tests, also based on our experience in multiple projects and POCs, we can confidently say that the accuracy levels of our face recognition is 99%. Apart from just being able to detect and verify a person, the software can actually provide different analytic tools. In our case, is unique visitors counting. And these are very applicable in many different industries and cases, specifically in the retail, shopping mall, as well as in the public sector as well, in terms of allocating the right resources and the right infrastructure. So in the world of a large data, and in the world where the collection of pictures and the collection of video streams is huge, it's very important to understand how the software can work with the big data and how quickly it can analyze a huge data sets. Thanks to our R&D team and developers, we have developed a module within our software that can actually searches through a database of 1.5 billion faces in less than a second. This is done due to the specific component that is within our software called Fast Index, which does break down the huge data set into smaller ones and searches through them in the parallel. This is one of the modules that is actually comes as an option depending on the use case and the project that's implemented, and can be turned on or off. So when we talk about face recognition, it is important to understand that is the software actually robust, and can it work with the non-cooperative wild video streams? In our understanding, initially when we started working on the technology, we've seen the market as already having its own infrastructure and environment. Businesses already having their own cameras, public sector and cities already with their own environment. So what was important to us is how do we create something that's hardware agnostic, can perform well in the non-cooperative video streams, and can perform well with the bad quality pictures. So what we have identified during multiple tests and POCs, that the software can actually perform having to detect only 40% of the faces. You can see in the case of the helmet here, this is one of the screenshots that we have made during our project. Also, because we are implementing projects around the world, it's important for the software to perform as well on different skin colors and different ethnicities, without any additional investment into the neural network retraining. And we have been able to achieve that. And as well, we are currently have currently developed a feature that's actually able to detect whether the person wears mask or not, because in our understanding, people and the governments are getting more aware of health and safety and the environment they are providing for their clients and their citizens. So everybody is trying to keep the social distancing, trying to keep the masks on. So it's very important to provide a biometric solution that's actually can support these entities in their objectives and goals. Apart from most obvious face features, we provide age recognition and gender recognition. And these features are developed more for analytical tools, and they are also recognized with a very high level of accuracy, and broadly used in the retail projects, shopping mall projects, public sector, and also during the public events. And understanding and segmenting the visitors into the different age groups, and also segmenting them into the different gender groups in order to make a weighed, efficient business decisions in the future. So all those features can be implemented within the software that we have developed specifically to be flexible and to have ability to integrate with the existing infrastructure of the business or entity we're working with. Whether you have your own VMS system or security system already installed, the software can easily be integrated with the third-party applications, and again, work with the existing infrastructure in terms of the cameras that are already installed. If we are talking specifically about areas in the city, if we are talking about the stores, the software can be integrated and used on the existing cameras. The other very important part, which we need to keep in mind when we are talking about the software projects, is the cost. And when we say cost in the software industry, we mean the hardware itself, and hardware and the computing power and the human resources that will be working on the project. And we were able to optimize our software in such a way that it actually requires fewer hardware resources during the implementation, and it works effectively on different types of hardware. So another question that I wanted to ask, and we'll leave some time in the live chat for you to answer: are you currently using face recognition technologies for mask detection? Yeah, if everyone had a chance to answer the question in the live chat, we'll continue. So when we're talking about the mask and biometric technologies and software in general, we need to understand that these solutions, they need to work and operate towards helping businesses and government entities to achieve their goals. So what we have developed in the last few months, and what we have actively been working on due to the huge demand, is how is the software currently is able to detect whether the person wears mask or not in real time. Secondly, I'm sure we've all seen cases where the people walking around in the public places wearing their masks below their noses, which is the incorrect way to wear the mask. So what the software does, it can actually detect and identify if the person is wearing a mask or not. Secondly, it can detect and identify whether the person is wearing the mask in a correct way or not. Also, straight away send an instant notification to the security guards or to the patrolling agencies, whether it's through the mobile phone or on desktop. And straight after the mask detection feature, the question that we get all the time is, and the question that we've been asking ourselves is, how accurate the performance of the software once we detect the face or we have the face covered with the mask, how accurately the initial core value of the software perform. Again, we've been conducting multiple tests with our ongoing clients and partners, and the performance more or less stays the same. The identification and verification of the software due to robustness, and because previously, initially to the COVID situation, this is something that we've been considering as our advantage. And this is something that we've been concentrating on. We still can perform with the same level of accuracy when people on the streets are wearing masks. We can detect and identify in real time. We can do it with the very high accuracy level. And again, the security guards or the policing agencies can get instant verifications on the matches. Another scenario that I wanted to talk about is how do I, these all features are very good. So how do I use them, and are they actual implemented projects where we can see the software working in real time and actually helping businesses to patrol their entities, to keep and help the environment much safer. So the example here is the project that's implemented in one of the shopping malls. And as you may know, in the past few months, the world has changed dramatically. The businesses are trying to adapt and struggling a lot in that sense. The governments are trying to adapt and implementing different new policies that will provide a safer environment for their citizens. And they are putting some responsibility on the business itself in terms of developing different policies that the businesses need to comply with. These are the things like social distancing, and these are the things like making sure your employees and your staff, as well as your visitors, are wearing masks to protect the people surrounding. So one of the use cases that we found here is this shopping mall and these retail stores, they actually get instant notifications and try to control their staff just to avoid different fines that are implemented by different government entities. Also, they try to identify the biggest and the least crowds where people are wearing masks or not wearing masks. And again, we were able to maintain a very high level of accuracy in terms of the recognition and in terms of the mask identification as well. When we talk about face recognition, the examples I've been talking about previously are closely related to the retail stores and the business malls, because these are the segments that are heavily affected during the quarantine and the pandemic, because these are the entities that were allowed to be open, that were operating during the COVID. However, they had to implement different measures. However, the face recognition is not limited to very specific number of tasks and can find a wide application in many different industries. Let's talk about them briefly. First of all, I'll go back to the retail and cover the numbers that they've been getting using the anti-shoplifting measures, leveraging the face recognition, and then we'll talk about other scenarios. So the stop shoplifting scenario is very straightforward, clear, and understandable scenario. This is the case that was implemented throughout Russia in more than 300 retail stores. And what happens is, whenever the person has committed a theft in the retail store, he's identified in a video stream, added into the watch list. Next time the person comes back to the store, the security guard, they get alerts to pay more attention to the person that did commit a crime previously. The numbers that we were getting from our partners are astonishing. The losses from the theft in Russia with this, in this specific case, were 2 to 4% of the revenue. And when we're talking about the scale of 300 stores, around the country, across the country, the 2-4% is huge numbers. So whenever we're talking about the private sector and implementation projects with them, the software, it's really important to understand their numbers. So the additional value that the biometric solution can bring is very important. The different analytics and the different tools that can enhance the business decision making and drive the revenues forward. These are the visitors per day counting, the visitors per hour, analysis of visitors and segmenting by different age and gender. For the retail specifically, the analytics like this provides a better understanding of their audience, a better understanding of their target market, in turn, which leads in a more enhanced and more specific promotions or adjustment of the layout within the store. The shoplifter portrait is something very interesting that our colleagues were able to come up with using the, again, leveraging the biometrics that's with face recognition and different features that it can actually detect and verify. So the interesting thing is before the quarantine, 60% of the shoplifters and the crime that was committed were committed. These people previously have committed illegal actions, as we can see here, and were alcohol intoxicated. And it was very dramatic to see the changes in the behavior and to see the changes in the portrait of the shoplifter that provided additional tools to tackle these crimes. So after the quarantine, 61% of crimes were committed by people that had never committed crimes before. and that were alcohol free. So these are the different scenarios, and these crimes are actually very different, because what happened after quarantine, these behaviors that people committed that were law-abiding citizens and committed the crimes alcohol-free are very difficult to predict. So the numbers that we were able to achieve in these projects are very interesting, and the numbers give us a lot of confidence that the technology finds a lot of use and can be leveraged by multiple businesses out there for many different calculations. And for analysis of 128,000 episodes, we were able to establish that the retail chains and stores, due to the Stop Shoplifting project, were able to save more than $2 million US for the businesses to identify such a loss and to actually prevent this type of a loss is huge, which leads us in understanding that in this specific case, the ROI for face recognition and biometric itself is 2 to 4 months. These numbers, they vary depending on the use case scenario and depending on the project. And this is very specific for the retail stores and the shopping malls. We'll go into the more details of where the software can be used to help the governments as well. So before we jump into the different scenarios that we can cover using our technology, I want you to answer my probably last question during our webinar today. Which scenarios you see for using such detection to improve business results? I'll leave 15 seconds for you to answer this question in a public chat. Great. So the areas of use of face recognition, again, as I mentioned, is quite broad. It can be used in public safety, anti-fraud, access control systems, visitors identification, accelerated services, and also in implementation of different analytical tools. Let's cover the project. One of the biggest projects that actually have been implemented in the last few years is the Moscow Safe City project. This is a very interesting case because we believe that this is one of the biggest real-time face recognition installations and one of the biggest safe city projects around the world. It has 105,000 cameras connected live to the face recognition, runs on the eMap where all different cameras are located, also allows you to connect and live stream the videos from these cameras, also to scroll through the archive. What's interesting about this project is, as you can see, 105,000 cameras requires quite a lot of computing power. Also, it requires a lot of storage. And how do we analyze all this storage, and how do we process all this data? So we were able to come up with different custom solutions specifically for this project that we are currently supporting as well, that allows the city to extend the storage time by 20 times for the data. And every month, the database expands by 10 million new images. The reason we actually bring this project as an example is to demonstrate the scalability of the software. So on the software level, there is no limitations in terms of how many cameras can be connected and also how many faces can be enrolled in a database. Another case that I want to talk about, and the reason I'm bringing these two examples today is they are very different from each other. In the Moscow project, we specifically work with the cameras that are already installed as part of the city infrastructure. In the FIFA World Cup, we worked with the cameras that we specifically installed on the metal detector at the entrance of the stadiums. We work with two stadiums, Luzhniki Stadium and Spartak, and also we put our security systems on the fan zone at Vorobyovo Gor. At the stadiums, we had the police had 50,000 people as a database and as a watch list. The people that were small hooligans, pocket picketers, the people that were forbidden to enter the stadiums, and these are the people that were stopped at the entrance of the stadiums. And also at the FunFest and the Fun Zone, the results the police were getting were very astonishing. There were 12 people arrested and found from the federal wanted list. And of course, we had different cases where people were trying to enter and penetrate different stadiums using hats, glasses, etc. There were cases where people tried to penetrate the stadium 5 times during a few days. And also there was a very interesting case where the Budweiser Cup that's supposed to be given to the man of the match after the games was stolen, and within 24 hours, the thieves were identified using the security systems based on biometric solutions as well. Another thing is just going back to the analytics that we were able to provide to the organizers of FIFA 2018 is the number of people that visited during different periods of times. So why this type of analytics is very important is for the big events like FIFA, it's very important for the government authorities and the city authorities to understand how much resources do we actually need to allocate for the specific venue in terms of logistics and in terms of movement around the city. How do we make the city more comfortable for our visitors? And for these goals, the analytics that we provided in terms of counting the number of visitors were very important. Provided very detailed information on visitors visited the zone over 25 days, how many people were visited, and then 271,000 people visited per day. So the implementation of the face recognition and the biometric solution might sound very complex because of the scenarios that I have explained previously. However, the implementation itself is very straightforward and requires minimum effort. How it happens is you request for installation package. The important part is the hardware part, where for 3 connected CCTV cameras, again, this could vary depending on the use case. This is the hardware requirement. As you can see, it could be a backend server, or this could be a gaming laptop with a GPU, an internet connection, of course, and we run on Linux as an operating system. And you're good to go. You just add cameras using RTSP streams, and you're good to go to detect. That's it. We'll jump into the questions from our live stream. Please feel free to ask all the questions of your interest. Let me have a look through the questions. So there is a question from Basma Al Mahmoud. Can facial recognition be more harmful than helpful? Well, this is a very interesting question, and the projects we are implementing, we have a good understanding how the software will be used and leveraged, and we position the software and for better environment, for the safer environment, to help if it's a government project, to help with the investigations and to help provide a more attractive and safer places for the tourists and for the citizens. So the software can enhance the operations of government entities and the businesses to make everything more efficient, which in turn, we believe if it's retail stores and businesses can drive the costs down. If it's government entities, they can allocate their resources more effectively. So there is a question on the shoplifter point. So the shoplifter case, again, is very straightforward. So whenever you have, let's imagine you have a chain of retail stores, and within this chain you have cameras installed in the stores, and you have people that are probably stealing from you. So what you do, you add this the pictures of the people that have been stealing from you in the watch lists. And next time the person comes into any of your retail stores, your security guards get a notification that they need to pay extra attention to this specific person. This in fact will reduce the number of theft attempts after the few arrests if they happen again. However, the analytics that was conducted by us together with the partners shows that people go back to the places where they've been stealing from. So this is something to think about, and probably we can share more details in the private conversation afterwards on the implementation of the project. So Al-Zah J, when the face mask recognition will be applied? Well, the face mask recognition is already released and is within our software and is already implemented in a few of the places. So whenever you have something or a business entity or a project that you need to work with detecting masks, please feel free to approach TRA and NCC. So, okay, so Basma Al Mahmoudour, I think this is the clarification from the previous question, just harmful in any ways if the camera footage got in the hands of someone with the bad intentions. Okay, I think I misexplained a little because we are not a VMS system. So we are just a software that can work with the video streams in terms of analytics, identifying the people, detecting the faces, etc. So we do not store the video stream footage just like VMS systems. We do not try to replicate them or compete with them. They are very different things. And I'm sure if we are talking about the retail store scenario, every retail store nowadays has VMS systems, which they use to record the footage from their stores anyways. Hopefully that answers the question. If you have more clarifications, please feel free to text. Okay, so Debong asking, from security point of view, the facial recognition applies to a person without a mask. Applies to a person. Okay, so so how will, okay, so the question is a little unclear. Oh, I can say there is a clarification. So how will the system be able to recognize the face if he or she is wearing a mask? Okay, it's a great question. Again, this goes back to the technology and how the software was developed. It runs on AI and based on neural networks. So the performance of the software heavily depends on how well the neural networks were trained. As I mentioned during the webinar, we try to concentrate and use the variety of data sets to train our neural networks. We concentrate on actually being able to detect the faces that are obstructed in some cases, or we have a very bad quality picture with the low density of pixel, or the face is very far from the camera. So answering your question is, yes, we can detect the face in the frame with the mask and identify, as long as the software can see or detect the 40% of the face being open. I think that's it for the questions. Dear colleagues, if you have more questions, please feel free to post them on live chat on YouTube. Thank you all for the questions.
Thank you, and Demir, for the very interesting discussion on a very valid point and pertinent to the security situation post-COVID. It is safe to say that the security industry will need to reinvent many of its central practices to adapt to the changed world. Thank you all for attending, and have a wonderful weekend. Thank you.
Okay, Mohammed, I think we have another question. And if you don't mind, I'll cover this. The question is by Fatima Darusos. Is there an explanation behind the strange behavior of shoplifters after the quarantine? Well, this is a very interesting question and a great topic for the discussion. We need to understand that the situation with the quarantine and COVID-19 had a huge effect and impact on the economics of the countries around the world. So the businesses were struggling to generate revenue. They were struggling to pay the wages, salaries, etc. So in our understanding, these were the shift were generated by the situation with COVID-19 rather than that's our belief, that it was shifted with the situation with COVID-19. However, there isn't any specific data to actually to provide an evidence that this was the case.
So I think that's it for today. If there's any more questions, this is your last chance to post it.
Again, thank you very much. Thank you, TRA and NCC, for your efforts to organize the webinar and everyone that was involved.
Thank you all for attending, and have a wonderful weekend. Thank you.
Thank you.